Good morning. Let's look at a few more questions on permutation and combination from past papers of 2017. A village hall has seats for 40 people, consisting of 8 rows with 5 seats in each row. Mary, Ahmad, Wayne, Elsie, and John are the first to arrive in the village hall, and no seats are taken before they arrive. How many possible arrangements are there of seating Mary, Ahmad, Wayne, Elsie, and John, assuming there are no restrictions? So, this question is a simple one. We are starting with a simple question. So, it's given that there are 40 seats. So, total number of seats is 40, and we have how many members? 1, 2, 3, 4, 5 members. So now at present we have 5 members with us. Now we have to arrange these 5 members out of 40 seats with no restriction. When it is no restriction, the arrangement is very simple, which is 40p5. There are totally 40 seats and 5 to be occupied, isn't it? Okay, so what we get that as, just do the calculation, we get the answer 78960 as answer. Okay, so this is a simple question. So remember, always with no restriction, you have to do the total number of arrangements within the given number. Okay, let's go for the second question. Question is, how many possible arrangements are there of seating Mary, Ahmad, Wayne, Elsie, and John if Mary and Ahmad sit together in the front row and other 3 sit together in other rows, in all other rows? So here you could find some conditions, some restrictions. That restriction is Mary and Ahmad sit together in the front row. So totally we have 8 rows with 5 seats in each row. So let's make the first row 1, 2, 3, 4, 5. Like this we have 7 more rows. That means totally 8 rows are there. So this is the first row. That means front row. So in this, what condition they have given is Mary and Ahmad sit together. So Mary and Ahmad sit together. Then how do you make that arrangement for Mary and Ahmad sit together? Let's make this one first, then we'll go for other 3. Let's find it. So totally we have 5 seats and 2 seats. 2 adjacent seats are occupied by Mary and Ahmad. In how many ways you can arrange it? You can arrange it in 4 ways, like 1, 2, 3, 4, 5. So these 2 seats can be occupied by Mary and Ahmad. That is one way. Or these 2 can be occupied by Mary and Ahmad. That is second way. Or these 2 can be occupied by both of them. Third way. Or these 2 is fourth ways. So totally we could find 4 ways to occupy Mary and Ahmad together in the front row. Okay, like if you think them as one group, just you think them as one group. This is one group, so remaining we have 3 terms, so totally we have 4 lines. So if you think them as one group, this line is meant for Mary and Ahmad, or this line is meant for Mary and Ahmad. That means when we make it as one group, this group becomes 2 seats, or this can be made as Mary and Ahmad, or it can be made as Mary and Ahmad. So totally we have 4 ways to arrange Mary and Ahmad in the front row. But now think about Mary and Ahmad. They can be changed their places. Like here Mary is first and Ahmad is second. So they can sit in a way that Ahmad is first and Mary is second. So they can be arranged themselves in the group in 2 factorial ways. Yes. So we get it as 4 into 2, 8 ways. That means in the front row, Mary and Ahmad can be arranged in 8 ways. And let us see the remaining part. Okay, so front row, Mary and Ahmad can be arranged in how many ways? 8 ways. Okay, let's think about other rows. We no need to draw all other rows. Instead of that, let's make only one row. If you know the arrangement of one row, that can be multiplied by 7 for the other rows also. So arrangement from the second row is same. Let's make second row 1, 2, 3, 4, 5, 6, 7. Here what they have given is, what they have given, and the other 3 sit together. Other 3, who are the other 3? Wayne, Elsie and John. They sit together. And they sit together in any one of the other rows. They may sit in second row or third row or fourth row or etc. They may sit in the 8th row also. Okay, let's find how do they sit in one row. How do they sit in one row? Let's find that. Okay, totally we have how many seats? 1, 2, 3, 4, 5 seats are there. We made so many seats here. Okay, so they may sit together. If they sit together, we can consider that one as one group. Okay, rest we have only 2 more groups, 2 more seats. So if there are 2 seats here, so if you think like that, that we have 2 seats, then this 3 may sit here like W E J, or they may sit here, or they may sit here. Yes. So how many places they have to sit? 3 places are there. Now look at their arrangement themselves. There are 3 people sitting together. They can be arranged in different ways. Like here Wayne is sitting first, maybe Elsie is sitting first, or who is the third person? John is sitting first. Like that, how many ways we can arrange? 3 factorial ways, which is 18 ways they can arrange. Who? Wayne, Elsie and John can arrange themselves to sit together in one row. This is for one row. Like this, how many rows are there? The same arrangements are possible for other rows also, no? Yes, that means total number of arrangements for them is 18 ways into 7. Why it is into 7? What is the reason it is into 7? Yes, because there are only 7 rows remaining, because totally there were 8 rows The first row is occupied by Mary and Ahmad to sit together. As Mary and Ahmad are sitting together, the other three never sit with them. Okay, so other three occupy the space in other seven rows. And when we thought about the other seven rows, when we think about the second row, there Elsie, Wayne and John sit together. So when they sit together, that arrangement can be made in such a way that they may sit here or here or here as together. So they can occupy three places. And if you think about their arrangement, in their group arrangement, that can be done in 3 factorial ways. So they can be arranged in 18 ways in one row. Like this, second to 8 rows we count, there are 7 rows. So the total arrangement done by Wayne, Elsie and John in other rows is 18 into 7. What is 18 into 7? 126. So now you think Mary and Ahmad could make their arrangement in 8 ways, and these three could make their arrangement in 126 ways. So the total number of arrangement will be 8 into 126, which is equal to 1008 ways. So they could arrange themselves in 1008 ways. Okay. Next question. In how many ways can a team or 4 people be chosen from 10 people if 2 of the people, Rose and Lionel, refuse to be in the team together? Okay, this is also an interesting question. In how many ways can a team of 4 people be chosen? So we have to choose. Remember, this is choose, means select. That means it is combination. From 10 people, you have to choose. So total there are 10 people. You have to select 4 people team. So team consists of 4 people. But there is a condition that 2 of the people from 10, 2 people were Rose and Lionel. They never played together. They don't want to be together in the team. That means if Rose is there in the team, Lionel refused to play, or Lionel is in the team, Rose refused to play. But both never be out. Okay, so how can we do this? Let's see what can we do for this. So here the best method what we can do is, let's see, suppose Rose is out, means Rose is not in the team and Lionel is in the team. In such case, suppose Rose is out, then means Lionel plays the games. So if Rose is out, out of 10, one person goes out. That means there are only 9 people remaining. From that you have to choose 4 people team. So we get 9C4, which is 126. 126. Okay. Now the second condition is Lionel is out and Rose is in. In such case also, out of 10, one person gone out. Who went out, whether it is Rose, Lionel or someone else, XYZ, doesn't matter. One person went out from the team. That means number of people became 9. From that you have to choose 4 people. So it is 126. 26. Okay. What if both are out? If both are out, what happens? If both are out, there exist only 8 people. From that, choose 4. 8C4, yes, we get it as 70. But we don't want both out. We want only any one of them out. Okay. Therefore, number of ways they refuse to play together is 126 plus, that means Rose is out, Leon is in, or 126, that means Leon is out and Rose is in, minus both are out, 70. We get it as 182 ways. Okay. Next question. Find the number of different 3-digit numbers greater than 300 that can be made from the digits 1, 2, 3, 4, 6, 8. If one digit can be repeated, if no digit can be repeated, sorry, no digit can be repeated. So we have to find the number of different 3-digit numbers. So we want 3-digit numbers. 1, 2, 3-digit numbers you want. And the condition given is that number must be greater than 300. And that can be made from the digits 1, 2, 3, 4, 6, 8. See, it can be done in two ways. Okay, it can be done in two ways. I'll show you one method. See, as the number is greater than 300, the first digit of the number may be any one of these, not 2 and not 1. So the first digit, that means this digit, may be either 3 or 4 or 6 or 8. Yes, if it is 3, these two places to be arranged with how many digits? Yes, total we have 1, 2, 3, 4, 5, 6 digits. One digit is already used here. So these two digits, two places to be arranged with remaining 5 digits. That means it can be arranged in 5p two ways, isn't it? Which is 20. And what about this condition here? Suppose the first digit is 4. The same condition now. There are two places remaining. These two remaining places to be filled with the rest of the 5 digits. That means it can be arranged in 5p2 ways. 20. Here also we get 20. And here also we receive 20 as answer. So total number of arrangements will be 80. See, the same can be done in another way, like when you look at the mark scheme, this is the arrangement they have made. So the first digit, what are the digits the first place can be taken? It's either 3 or 4 or 6 or 8. Yes. So if 3 is chosen, just think 3 is chosen, then what are the digits can be taken in the second place? It may either 1 or 2 or 4 or 6 or 8. Okay, now if 1 is chosen, what are the digits can be taken for the third place? Yeah, it may be any one of these, like it may be 2 or 4 or 6 or 8. Yes, now look at the first place. How many digits can be placed? 4 digits. Into the second place, we can place totally 5 digits. Into third place, still we have 4 digits. So when you multiply, we get the answer as 80. Okay, see, the same condition is possible for other arrangements also. First place 3 is chosen and second place 2 is chosen. If 2 is chosen, then the next arrangement will be like 1 4 6 8. Okay, suppose first place 6 is chosen, second place 4 is chosen, so the next arrangement will be 1 2 1 2 3 8. That time this 3 comes here. Okay, so totally there are 80 arrangements with no digits can be repeated. Okay, but when it come to the next question, a digit can be repeated and the number made is even. So here we have two conditions. Not two conditions, there are three conditions. First condition is number should be more than 300. Second condition is number should be even, and third condition is the number can be repeated. So in this arrangement, it is very difficult for us to make an arrangement with the permutation formula or combination formula directly. So what we do is just like our previous question, previous method we do. We'll see in each place how many numbers can be taken. Okay. So here we have three places. Our numbers are 1, 2, 3, 4, 6, 8. Let's take the first condition. As per the first condition, number is greater than 300. Number should be greater than 300. So these are the digits can be here. It can be 3, 4, 6, 8. Okay, so it can choose 4 places. Now the next condition is number should be even. These 4 places it can be taken here. That is why this 4. Next condition is number must be even. As the number is even, what should be the last digit decides the even number or odd number, right? As the number is even, what are the digits can be occupied here? Yes, it can be either 2, 4, 6 or 8, or 4 or 6 or 8. It never comes together. Any one of this arrangement is possible. That's why we take only one chance there. That's why previous question it was 80 arrangements. So here how many digits can be arranged? 4 ways. Okay, now what are the digits can occupy in the middle space? There we use the third condition as digit can be repeated. So as the digit can be repeated, the middle place can take any of these 6 numbers. Middle place can take any of the 6 numbers, that is can be take either 1 or 2 or 3 or 4 or 6 or 8, as the digit can be repeated. So middle place can take any of the 6 numbers. So totally we get 4 times 6 times 4. which is 96. So totally in 96 ways you can arrange the numbers with the given conditions. Look at the next question. A team of 5 is chosen from 6 boys and 4 girls. That means totally 10 students. Find the number of ways the team can be chosen if there are no restriction. So it's very simple, as there is no restriction and it is meant for chosen. It is combination. So totally we have 6 boys and 4 girls. That means totally 10 people. Out of that, choose a team of 5 members. So we get it as 10C5. Do calculation. We get 252 as answer. Okay, it's very simple. Let's go for next question. The team contains more boys than girls. The team contains more boys than girls. Number of boys must be more than girls. And you have to imagine there are 5 members in the team. If you want to make number of boys more than that of girls, the minimum number of boys should be 3. Yes, then only number of boys more than girls. So how many ways you can arrange? Like 3 boys and 2 girls. We can arrange now? Yes, or 4 boys and 1 girl. That arrangement is also possible? Yes. Or 5 boys and no girl. That arrangement is also possible because they have given the condition that number of boys is more than number of girls. Other than that, nothing is given. Not arrangement, sorry, it is selection. Okay. Now, how do we make this selection? 3 boys and 2 girls. 3 boys out of 6 boys. So 3 boys can be arranged as 63 ways. And 2 girls out of 4. So 4C2 ways. So totally we get 6C3 into 4C2. It is 120. Now this arrangement. 4 boys out of 6. So 6C4 into 1 girl out of 4. So 4C1. We get it as 60. This one 5 boys out of 6. So it is 6C5 into 4C0. 0 girls out of 4. So we get the answer as 6 here. So if you take the total of this one, we get 120 plus 60 plus 6 as 186. So there are 186 ways to arrange the team with this given condition, that number of boys is more than the number of girls. When you look at this question, a car park has spaces for 18 cars arranged in a line. On one day, there are 5 cars of different makes parked in randomly chosen positions and 13 empty spaces. So there are 18 cars, 18 spaces. From that, 5 cars are parked. That means 18 spaces are empty. Find the number of possible arrangements of the 5 cars in the car park. Number of possible arrangements. It is arrangement, so it is permutation. So there are 18 spaces in that 5 cars to be arranged in 18p 5 ways, which is 1028160 ways can be arranged. As first question, it is simple. Let's go for the second question. Find the probability that 5 cars are not all next to each other. So here a condition is given. Find the probability that 5 cars are not all next to each other. All the cars are not next to each other. All those 5 cars are not next to each other. They should not be together. So how can we do this? As the number is more, one of the good options we have is you have to find the total number of cars. Total arrangement. We already done total arrangement now. That is 18p5. From that, delete 5 cars together. Is it? From total, if you delete 5 cars together, we get 5 cars not together. Yes. So let's find 5 cars together now. 5 cars together. So 5 cars are together and there are 13 more places. Okay, that means we can find totally 14 places. Isn't it? Totally we could find 14 places because there are 13 places here and for these 5 cars, 1 place. So we'll take the total 5 cars as 1 place. That is why 1 place plus 13. So totally 14 places. So there are 14 places the cars can be arranged, and when we think about these cars, they can be arranged in 5 factorial ways. So we get 14 into 5 factorial ways the cars are together. Therefore, number of ways cars are not together is total arrangement. Total arrangement is 18p5. Already we found the value of that. I couldn't find it in this. Minus cars are together. 5 cars together is 14 into 5 factorial. So we get the answer for that is 1026480. Okay, now we need to find the probability of this event, which is 1026480. That means 5 cars are not together divided by total. Total is 18p5. That is something we got 1028 or something. Okay, so when you do this calculation, we get the answer as 0.998 as a result. So you don't get any confusion in this. Why? Because how do we make that arrangement? Like suppose 13 arrangements you make. 1 2 3 4 5 6 7 8 9 10 11 12 13. Of course 14 15 16 17 18. Okay, so if these are the spaces occupied for 5 cars, suppose, then remaining how many places are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 places. Instead of that, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Suppose these just randomly I am selecting 5 places. 1 2 3 4 5. These are the 5 places. They are together. You just think. So how many places are there now in total? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. That is why totally there are 14 places for them to be together. and when you arrange them in order in randomly, can be arranged in 5 factorial ways. So this is the togetherness of 5 cars. So from total is 18p5. So from total, if you delete this answer, we get not together. 5 cars not together. I hope you got it. On another day, 12 cars of different makes are parked in the car park. 5 of these cars are red, 4 are white, and 3 are black. Elizabeth selects 3 of these cars. Find the number of selections Elizabeth can make that include cars of at least 2 different colors. So here Elizabeth want to select 3 cars. When she select 3 cars, it should be in such a way that she has to select at least 3 different colors. So it is a bit difficult to find at least 2 different colors, not 3, at least 2 different colors. So instead of finding at least 2 different colors, we can do it in another way. That is, from total number of cars, from total selection, if you delete one color cars, selection of one color means like what will say, what are the colors we have? We have red, white, and black. So from the total selection, if you delete this one colored cars, what you will get? Minimum 2 different colors cars, no? Yes. So let's see what is total. And as it is a selection, is it selection or arrangement? Yes, selection. As it is a selection, the total selection is 12C3. Okay. Now, selection of red cars. Selection of red cars is, we have 5 red cars. From 5 red cars, if you select 3, we get 5C3. Similarly, selection of white cars, we get it as 4C3. And selection of black cars, we get it as 3C3 ways. Okay. So from the total selection, if you delete the selection of only red cars or selection of white cars or selection of black cars, that is we get 12C3 minus 5C3 minus 4C3 minus 3C3. We get the answer for this question. Or it can be done in more specific way, like we need at least 2 different colors. Okay, I'll show you some shortcut. You just continue with the remaining part. At least 2 different colors means, suppose I'm taking the colors as red, white, and black. Red, white, and black. So we can make many chances, like all the 3 are different color, at least two different colors. All the two are different color, all the three are different colors. There are two reds and one white. Black is not there. There are two reds, zero white, one black. Okay, now there are two whites, one red, no black. Or there are two white, one black, no red. Or there are two black, one red, zero white. There are two black, one white, zero red. Okay, now how do you find these answers? Using selection, you have to find out these answers one by one. Okay, like red, we have 5, 4 and 3. So one red is chosen. The first selection is one red is chosen out of 5. So it is 5C1 into one white out of 4. So 4C1 into one black out of 3. So 3C1. So we get it as 5C1 is 5 into 4 into 3. So we get it as 60. Similarly, when you think about this one, 5C2 into 4C1 into 3C0. That is 5C2 is 10 into 4, 40. Similarly, this one, which is 5C2 into the 0 part, no need to write. So 3C1. So 5C2 is 10 into 3, 30. Now this part, 5C1 into 4C2. 0 part you can avoid because that gives 1. 5C1 is 5, 4C2 is 6, 5, 6, 30. In this case, 5C1 into 3C2. So what is 3C2 is 3, no? So it is 15. So here red is not there. So 4C1 into 3C2. So which is 4 into 3, 12. So add all those things like 60 plus 40, 100, 130, 160, 175, 187. So I hope there are 187 ways to arrange the cars in such a way that 3 cars must have at least 2 different colors. This is another way by specifying everything. Otherwise, like previous question, what we have done, from total we have to delete such a way that all the 3 are red, because we want only 2 different colors maximum. At least 2 different colors should be there. Here only one color is there, so that can be deleted, which is in 5C3 minus if all the 3 are white, that can be deleted. This 4C3 minus if all the 3 are black, that can be deleted, that is 3C3. And total is 20C3. From that delete 5C3, 4C3 and 3C3. This is by the reverse process we are doing. From total delete the same color, we get different colors. That's the thing we are doing. Okay, thank you.